Hello everyone, welcome back to Kapil Joshi tutorials. In this video, we are going to understand a simple but very important example that is commonly used in machine learning, data mining and AI to explain classification problems. So here's the problem. Problem means let us consider the following scenario. We have data of patients entering a clinic. For each patient, we are giving three attributes. First is gender. Gender means male or it can be female, denoted by M or F. What is age? Age is just about the numerical numbers or numerical values. Another attribute is label, either healthy or sick. So basically, this is a labeled dataset where the output class is already known. So understanding the dataset, that's the main point. So let us look at the table carefully. So each row represents one patient and another term that is denoted by the number of things. Like for an example, first patient is male, that is 48 years old and labeled as sick. Second patient is male, 67 years old and also is sick. So third patient is female, 53 years old and labeled as healthy. It's very simple. So and so on. So we can clearly see that the gender and age are just input features. So label, as we know, healthy or sick is the target output. So if we talk about the types of machine learning problems, so we can say the classification of machine learning problems. So this example represents a supervised learning problems. Why? Just because of we already know the correct output that is labeled for each input. The goal is to learn a pattern from the data. So more specifically, this is a binary classification problem just because of there are only two possible classes, healthy or sick. We already discussed there are two labels, healthy or sick. So why is this dataset important? So this kind of dataset is often used to explain decision tree, naive Bayes classifier, k-nearest neighbors, logistic regression, etc. So this idea is very simple and very ordinary. So it is based on gender or age. So we want to predict whether a new patient is healthy or sick. So we can easily find out all the points. So what does it mean? Pattern observation. We can say human intuitions, like even before applying any algorithm, let us try to observe patterns manually. So we may notice that many older patients are labeled as sick. Younger patients tend to be healthy. Gender may also play a role depending on the dataset. So this is exactly what a machine learning model tries to learn automatically. It just tries to learn automatically and predict the data. So how a model would use this data? So in machine learning, gender may be encoded numerically. For an example, M is equal to 1 and F is equal to 0. So age is already numerical. So the model learns a rule like if age is above a certain threshold that is known as sick, otherwise it would be healthy. So different algorithms learn this rule in different way, that is a predicting task. Or once the model is trained, we can ask question like a new patient comes with, that is gender male, age is 50. So will this patient be healthy or sick? This will be the question. and the trained model will use past data to make this prediction. Like we are saying real world relevancy or real world relevance. So we can say just kind of this example may look small, but it represents real world medical decision system such as decision risk prediction, hospital triage system, health monitoring application. So in terms of real-time application, instead of just two features, we may have blood pressure, cholesterol, sugar level, lifestyle factors, but the core idea remains the same. So we may summarize this slide that is just a labeled patient data. So what will be the output? What will be the input? Input is gender and age. Output, healthy or sick. Type, supervised binary classification. What does it mean? Goal. Goal is just a learning process. Learn a model that can predict patient health status. So that's all from this video. If you found this explanation helpful, please like, share and subscribe to Kapil Joshi tutorials. Thank you and see you in the next lecture.